I've already talked a little bit about the idea of continuity of a couple of trig functions, specifically sine and cosine. Let's take a look at the others now. All trigonometric functions are continuous everywhere on their domain. Okay, so what does that mean? Well, sine of x has a domain that's equal to all real numbers. So it's continuous everywhere. When you look at a graph of sine, it looks like this. Cosine has a domain that's also equal to all real numbers. And that graph is similar. It looks like this. And goes on to plus and minus infinity. Tangent of x is another story. Tangent of x is actually equal to sine of x over cosine x. As a quick review, all trig functions are made up of sine and cosine. So once we have sine and cosine figured out, everything else, all the others are made up of sine and cosine. So tangent is sine x over cosine x. The domain equals is all real numbers such that cosine of x is non-zero. That means x is not equal to, well, where's cosine 0? Well, cosine is going to be 0 at pi over 2, 3 pi over 2, 5 pi over 2, and I could make this plus or minus, plus or minus, plus or minus, depending on which way you're going. All the odd pi's over 2. So in other words, x is not equal to 2n plus 1 pi over 2, and of course I can make that plus or minus. 2n plus 1 for n is one of the counting numbers, is in the set 0, 1, 2, 3, so forth, etc. This will always guarantee, this is good to remember, this will always guarantee that you have an odd number provided this is how n is defined. Cosecant of x. Cosecant is equal to 1 over sine of x. And that's going to be continuous, again, everywhere in its domain. But what I need is the fact that it's continuous, say, for all x, such that sine of x is, in fact, non-zero. Well, when is sine 0? Sine of x equals 0 for x equals 0, pi, 2 pi, so forth, etc. So I can say for x equal to n pi, for again, n is in the set 0, 1, 2, so forth. Actually, I could make every one of these plus and minus. Secant is very similar, but secant is actually equal to 1 over cosine. And we already figured out where cosine is equal to 0. So the domain is going to be actually the same thing as for tangent. I'm going to have the same vertical asymptotes. So what I need is x to be not equal to 2n plus 1, I'll say plus and minus, pi over 2. Every place else, it's continuous. Cotangent is equal to 1 over tangent, which is same as cosine of x over sine of x. So again, I need to know when sine of x is non-zero, and that we outlined right here. So this domain is going to be the same. The domain of cotangent is actually the same as the domain of cosecant, which means this is continuous for all x not equal to plus and minus n pi.